Okay, so now we have an example with that fruit fly population that we did earlier. Suppose a scientist is comparing a population of fruit flies to a population that progresses through its lifespan twice as fast as the original population. So what does that mean when it's occurring twice as fast? So if the time is in hours, at 1 hour, P of t has so much population. But in the new one, we'll call it Q of t, it's going to happen in half that time. So the population I had at 1 hour for P of t is only taking a half hour at Q of t, because Q of t is twice as fast, okay? All right, they explain a little more. In other words, this new population R, they call it R. Okay, so I guess I don't get to call it Q of t. I'll call it R, like it says. Will progress in 1 hour the same amount as the original population does in 2 hours. In 2 hours, it will progress as much as the original population does in 4 hours. Sketch a graph of this population. So ask yourself, do you think this is going to be a stretch or a compression? It's not scrolling for me. Why is that? Let's see. Okay, there it goes. There's my population. All right, let's think about this a little bit. Right here is a point 3, okay? And so when we have t being 3, I'll make a little table of values here. When t is 3, the population is 3, it looks like, okay? So what's happening over here on my other chart, for my new function r of t? Well, if I want an output of 3, then what happens is I'm cutting the time in half. So it's going to be 1.5, okay? So my new function is going to be 1.53. So it's compressing. See if I can get that out of there. Compressing to half the amount of time, okay, because it's growing faster. All right. What happens at the point 0? When the time is 0, you have a population of 1. Well, that's going to stay the same. Okay, so 0, you're still starting with 1. So that point's going to stay the same. Now let's look at this point over here. 6, input of 6 in the original, and getting an output of 2. So what does that mean? Remember, the whole thing's going twice as fast, so it's taking half the time. So when it's 3 hours, that's when I would get an output of 2. So then I'm going to have a little point right there. And then there's one more point we need to consider, 7. 7 says the population is 0. So in half the time, half of 7 would be 7 halves, or 3.5. And the output is going to be back to 0. So that's how this is going to look. Now when you graph this, because they've only given us a graph here, you have to keep the shape the same. I'll try. So you have that curved part. It might even need to be a little more curved. Well, now it's just going to be a thick, curvy line. Anyway, and then you have that straight part here, and then another straight part going there. Okay, so it's a little thicker than I want it to be, but that would be the graph then. So it's compressing. In symbols, how would you write it? You'd say r of t equals then p of, now it's a compression, right? So it's going to be 2. It's got to be the reciprocal. We're compressing it by a half, so the reciprocal is going to be 2t. And you could plug in t values and see if that works. When you plug in 1.5, you get p of 3, but we know p of 3, it's 3. And you can go through all the points that way. Okay, so hopefully this is helping. We still have some more tables, or some more examples.